Section 7, you have to know your trig identities. So these are 4 that you have to memorize. There's really no other ones besides that secant is 1 over cosine and cosecant is 1 over sine and cotangent is 1 over tangent, and tangent is sine over cosine. That's pretty much all there is. These 2 are not all that important, but they might show up on a quiz or a test somewhere. So I'm going to give you a list of things the first week of school that you have to just start memorizing because they're just going to show up, and these are 4 of those things. Here are some trig equations. In order to solve trig equations, you have to have a little bit of creativity. You have to realize here that you can't solve something that has a sine and a cosine in it. It's just not possible. You have to get rid of something. Hopefully you recognize sine squared as a trig identity. So you can replace sine squared with 1 minus cosine squared. You also could have replaced cosine squared with 1 minus sine squared. That would have been totally fine. Either way, here's the algebra. Distribute, subtract cosine squared from both sides, which gives you 3 minus 4 cosine squared equals 0. Subtract 3 from both sides, and then divide by -4. So you end up with cosine squared equals 3/4. So therefore, cosine equals plus or minus root 3 over 4. The square root of 3 over 4 is the square root of 3 over the square root of 4, which becomes root 3 over 2. And it's plus or minus because when you take the square root, you need the positive and the negative. So you have 4 possible solutions here. And again, if you put this into y1 and this into y2, you will see they cross in 4 places. It's a little bit tricky, I'll have to show you, because you can't type sine squared in a calculator. You have to actually type sine times sine. So you would type 3 sine x times sine x. And then for the y2, you would do cosine x times cosine x. And see where they cross. Make sure you're in radians. Anytime you graph a trig function in calculation, you need to be in radians. To get your 10 by 10 window, we're going to go zoom 6. Oops, zoom 6. Now you can see it better. I think. Oh, right. Zoom 6 is silly because it's a trig function. It's only defined from -1 to 1 on the y-axis and -2 pi to 2 pi on the x-axis. So this was silly. Negative pi to 2 pi. I might have typed something in wrong because it still didn't quite look right, but you'll find that I make mistakes too. -1 to 1. If those don't cross, then I type something in wrong. What did we do? Good thing I know how to edit this. Three sine x sine x. I bet I am not in radians. Oh, look at that. There we go. Now we're talking. Now the instructions said from 0 to 2 pi. So you can see from 0 to 2 pi there are 1, 2, 3, 4 points of intersection, which is exactly what we found. Okay, and then here you have to use that the identity for a double angle is 2 sine theta cosine theta equals sine theta. Now your instinct here is going to be to just cancel those out, but let's think about something. Think about the equation x squared equals x. If you just divide both sides by x, you get x equals 1, which I agree is true. When you plug in 1 for x and you square it, 1 does equal 1. But when you do that, you automatically eliminate the other answer of 0. So you have to be careful just dividing both sides by a variable or a function. We're better off subtracting it from both sides, making it equal 0, factoring out an x, and then realizing that it has two answers. So same idea here. Don't just divide both sides by sign. You need to subtract sign from both sides, factor out a common factor of sign. So now you have a t-chart that says a number times a number equals 0. So either sine of theta equals 0, in which case theta would be 0 or pi, or 2 pi, or 2 cosine theta equals 1, so that cosine theta equals a half, and that would be, where does cosine equal a half? At pi over 3. And is that the only answer? Because cosine's also positive in the fourth quadrant. Why didn't I use that as an answer? I think it should also be 5 pi over 3. Let's see. Let's see what our trusty little calculator says. Sine of 2x and sine x. Delete, 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 delete. Graph. Let's see how many answers there are between 0 and 2 pi. I should have changed my window so that I only had to look at it. But live and learn, live and learn. Okay, between 0 and 2 pi we have 1, 2, 3, 4, looks like 5. So we do have to include the 5 pi over 3. Good to know, good to know. Okay. Piecewise function. You have to know how to graph these. So basically, x squared plus 1 is a parabola that's shifted up 1 unit. And so from 0 to 2, we just evaluate it at 0, 1, and 2, and it's a parabola. It looks like that. From 2 to 4, that's from here to here, it's a line 2x plus 3, where the slope is 2. When we plug in 2 for x, you see that it starts at 7. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Slope of 2, up 2 over 1, up 2 over 1. So this is the second part of the piecewise function. And then when x is greater than or equal to 4, it's just 10. So it's a horizontal line where x is 10. So the question says, is it continuous at x equals 2? The rule about continuity is simply, if you have to pick up your pencil, it's not continuous. So as I trace along and I get to x is 2, it jumps up here, so that is not continuous. The definition, the reason you have to use to justify it, is to say that the limit from the left and the right are not the same. So the limit as x approaches 2 from the left, so that means you start on the left and trace your pencil. As you get closer and closer and closer and closer to 2, you are at 1, 2, 3, 4, 5. And remember, we knew that because if we had plugged in 2 here from the left, when it's smaller than 2, we'd get 5. When you evaluate it from the right, so start over here at the right and come on and get closer and closer and closer and closer to when x is 2, your answer is 7. Because this is coming from the right, if you plug in 2 here, you get 7. So since those two things are not equal, it's not continuous. Same thing with x equals 4. From the left means evaluate it here, and you get 11. From the right means evaluate it here, and you get 10. Those are not the same, therefore it is not continuous. So how many more pages do we have here? Okay, I'll go through this page and then I'll start a new section. All you have to recognize here is that the radius is 4 and the height is 12. So you're comparing 4 to 12. Write an expression for r as a function of h. I always get confused about what is a function of what, except I always remember that most of the time we're dealing with y as a function of x. So something is a function of, that's what you do with the, that's what you put before the equal sign. So r as a function, r acts like y. And so how is r related to h? It's 1/3 of h. So r equals 1/3 of h. H is a function of r just means solve this for h. So you get h equals 3r. Then you have to know the volume of a cone is 1/3 pi r squared h. This is one of those things that's going to show up a lot. You have to memorize it. I'm going to have a list of things you have to memorize. This is one of those things. But we only want it as a function of h, which means it can't have an r in it. So we have to replace the r with what it's equal to, which is 1/3 h. And then we have to evaluate. Well, when you square 1/3 h, you get 1/9 h squared. So I have the same exact thing written here. I have 1/3, 1/3, pi, pi. R squared, I've now replaced it with 1/9 h squared, and then h. Multiply the h's, multiply the 1/9 by the 1/3, and your final answer is 1/27 pi h cubed. Do the same thing here, 1/3 pi r squared, but instead of h, we're going to write what h is equal to, which is 3r. The 3 and the 1/3 cancel out. R times r squared is r cubed, and you're left with pi r cubed.